All right, let's talk about the cylinder barrel. So technically, this is a cylinder, and if we split it in two pieces, this is the barrel, and this is the head. Head is made of aluminum. The barrel is made of steel. It is actually screwed together. So here's a, I'll leave that up there, you matter. Here's a cutaway of one. So it have all these threads on there. So the head is just screwed on an index, so they all face the correct way. So this is the cylinder barrel part. The cylinder barrel, it's made of high-strength steel alloy. Obviously, it has cooling fins to dissipate the heat. That's not accurate. Let's move on to this one. Let's see. Loss of cooling fins is bad, so a loss. Cooling fins creates a hot spot. What is a hot spot?
A spot that has more heat than the rest.
It's a place where you get your Wi-Fi.
There you go.
So you get a spot that is actually hotter than the rest of it. Well, that's going to create all kinds of problems. I suppose everything from stresses within the metals to if it gets hot there. If it got hot enough, you could have light off fuel air mixture. That'd be pretty freaking hot. So, but yeah, you don't want that. So what do we do with damaged cooling fins? So, damaged cooling fins. You have to be careful because each manufacturer's has different guidelines. One of them says you can't even straighten them, and if it's bent more than halfway to the next one, you have to scrap the cylinder. Yeah, so you just look at the manual and follow what they want.
I think it said you could weld like specific cooling fins.
Yeah, it's going to depend upon the manufacturer. So I'll say see overhaul manual. That's the best way to do it. Generally repairable, if not into the base material. Once it gets into the base material, for sure it's gone. And what I mean by that is a fin breaks, part of the fin, that's one thing. If it goes all the way back, you're like, wow, the entire fin is gone and it's now into the not fin area. That's, you're done. So, bent cooling fins, they're usually left alone. Although, I don't know, around here I'll straighten them, but it's just a school, so it doesn't matter. Well, they're not airworthy, so I can do whatever I want, right? All right, the surface. The bore surface, that is. I should say bore surface. All right, we have a lot of different bore surfaces. So there are different materials. First of all, they're all made steel, but then what is it you're going to put on the inside of that bore? We could categorize it into plated and non-plated. So we'll talk about non-plated.
What is that word? It says no.
Materials, M-A-T-E-R-I-A. Boy, that doesn't look anything like what I tried to write. Materials. My bad. All right, so non-plated, and this is all review at this point. So what am I non-plated? Well, we have the plain steel. Plain steel. What's my other one?
Chrome.
No, that's a plating.
Nitrate.
Right. All right, so what would be the problem with plain steel? What would be my...
Rust.
Well, versus the other one. So plain steel would have poor wear characteristics. It has better rust preventative.
Plain steel is better than nitrated?
Oh,
I
yeah.
don't know much about it.
Yeah, so plain steel, it's going to have poor wear characteristics. Most all Lycoming stuff. Now, Lycoming differentiates. I mean, they make a thing of it. It's like, no, this is plain steel, that's nitrated. Continental, like, it's our cylinder. Well, what is it? Well, if you must know, they're nitrated. I mean, it's kind of the way they act. All of them? Yeah, all of them. Why wouldn't we not nitrate them all? Don't worry about it, And then Lycoming makes these huge distinctions between the two. And then there's nitriding, which is not a plating. What is nitriding?
Chemical process.
A chemical process. And what does it do? It makes it hard. So if it's harder, it is going to have,
Better wear characteristics.
yeah, I said great. We should just say better. Better wear characteristics.
So the chrome would have the best wear characteristics.
But the problem is,
Corrodes horribly.
easily rusts. Very easy.
Just the nitride
The
process
nitriding process causes it to.
vulnerable to oxidization.
Mhm. Terrible. And now, this is new. There's black oxide, which I'm not 100%, but I believe it's a nitriding with a black oxide finish that just protects the coating to keep it. But I'll just say it's black oxide, so it's got a black finish to it.
What's the best?
I think, well, if I had to choose, well, my engine is nitride because it's Continental. It's just that's the way they come. So,
So is a chrome? You're saying about chrome was something they used to do to repair it, and they built them up.
right. Well, now we can talk about plated.
Okay. I have questions.
All right, he has questions. Now we have, so, yeah, if I have my history right, not that it's super important, I believe that chroming was originally invented as a repair. So you had a cylinder, and maybe they had standard and then bored them out and then plated them back to standard, right? So there is no such thing as oversized plating. It just doesn't exist. You'd have to bore it out too far to plate it, I guess. So if it's plated, chrome, something like that, it's standard. It's just the only way they come. So, but there's a lot of plating. So one of the first ones they did was chrome. They call it cracked chrome or channel chrome were the names given to it because it is cracked. And what the cracking is, therefore, and what I was told is what they do is plating is a process where you have a current going through something, and what they do is they quickly reverse the current, and it blasts pieces off, and it creates the cracking look that you see on here. And so if you, I'll pass this around. If you look at it, right, this is the top up here. If you look at the top where the most wear is, you can see how this cylinder actually wore through the plating at one point, and then right next to it, it's got a mirror smooth finish. That's bad, right? All the channeling is gone, all the cracking. But the channeling is there to hold oil because it's so hard. Now, we still honed them, and you can put a little bit of a cross hatch on them, but not much. So, but the channeling is supposed to be there. So, chrome worked, but then somebody decided and so chrome does have an orange stripe, so I'm not going to rattle this because I'll run out of what I remember. But see, hold that up. It has an orange stripe. That means it's chrome. It's color coded. So you put it down there at the base, orange, chrome. So then we had ceramic. So they came out with a ceramic coating. So they called it was a ceramic chrome, and they called it, I'll just put ceramic. Chrome was just called chrome. And then
Cerakote?
No, I was trying to, give me a minute. Stop it, foot there. Cermachrome.
Summer chrome.
Certified.
Really creative.
Cermachrome. Ceramic chrome. That was weird stuff. It had like a ceramic coating on top of the chrome, and it was this kind of a dull gray, glassy finish. That doesn't make sense. It was a dull gray, and it was weird stuff. I remember we built an engine with this Cermachrome on it, and built a couple of them, and people would. So, I wasn't in the engine shop, but anyway, it was before we were doing. I got the test stand, so kind of the procedure was, disassemble, clean, repair, reassemble, and test, right? So there's tests, but they just strap it to the front of an airplane and say, go fly your new engine. And so people go fly and come back, and you look over the engine and you pull out the dipstick, oil level gauge, excuse me, because we're fancy. And there'd be this layer of fuzz, weird chromy ceramic stuff floating on the oil, and it just was on the dipstick and everything. And like, wow, that's weird stuff. And we even talked to people, as they were flying these things, they go to break in. They say you could just see it. The cylinder head temp goes up, 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 up. They're like getting to a point where it's like, oh dear God, that's bad, and pop, almost like they flipped a switch. It just starts going back the other way and go, oh, they're broken. That's kind of how it worked. So I hated that stuff. And then they came out with this new stuff that I hated even more with nickel in it. And they called that, now I forget, Sermonil. Actually, it was spelled Serma, no, with that big N. Big C, big N. And these are trade names. So Chrome had one orange stripe. Sermachrome had two orange stripes. Sermonil had two turquoise. I don't know how to spell turquoise.
Teal.
Thank you. Teal stripes. I did not like that stuff. Oh my gosh, was this stuff. It was so hard. We had this incredible hone that I don't want to bore you with, but you put one cylinder on at a time, and then we just had a faucet on the side that controlled hydraulic pressure, and then a hydraulic a PSI gauge on the side. And I don't even remember anymore what it went up to. I think like 150 was the middle. You just bring it up to 150, and these stones would go up and down inside the cylinders. It's going up and down, and you just controlled how much the stones were pressed out. There's a ram that came up the middle of the stones and pressed them out. And we used it to bore cylinders over and everything. It wouldn't touch this Sermonil stuff. So we had to have the special kit from the manufacturer, which was just a hone that went on a drill. So I'm like, now I feel like we went backwards in technology, but they were diamond encrusted, whatever you call them, stones in it. You had to use this special fluid to lubricate, and you did it. Well, so one day I had a Sermonil cylinder in the shop, and I was working on it, and I put it in the oven because I had to change out the guides. And I'm over here doing something, and I hear this pink. And I look over, and all the Sermonil just slid out of the cylinder and landed on the floor. And I'm like, called the manufacturer, like, yeah, that stuff doesn't do well with open flame.
What the fuck?
So, yeah, that's literally what they told me. So I'm like, okay. I'm like, oh, that sounds not good. Yeah.
How did they get so that's not the cracking in there, that's not cross-hatching?
No,
What is it?
it's the chroming process.
So chrome is cracked. It'll look cracked?
Yeah, I think they reversed the voltage on it, or the current. Reverse the current on it, and it kind of does something. Because it's a plating process that uses current. I'm not a chrome expert. How you do chrome, I don't.
So do you hone chrome?
I do, yeah. We did, yeah. Yeah, you put little scratches in it. They go away pretty fast, but you still do it. Did it to all of these. Well, those are the three I know about. That aviation uses. I think Sermachrome is long gone. I don't know if anybody's doing nickel anymore, but I think chrome has just managed to stand the test of time. It really is the least problematic. So, what are the characteristics? What about it?
That makes me feel better about mine.
Do you have chrome? Yeah. If I had to if I had chrome, so I don't know. I'd be like, oh, okay.
Everybody keeps telling me like you're gonna give about half the search and
Half the what? Half the life out of it?
yes, people tell me. But I mean, that's just hearsay. I don't really know.
I'm not aware of that. Yeah. Most of the problems with cylinders are valves. And that has no effect on the valve. So, start burning a little more oil maybe at some point. I don't know. I don't see a problem with it. So, characteristics of plating. Well, you have no rust. No rust whatsoever. So, check. I freak out if my airplane doesn't fly every week because of rust. Everything rusts so fast. So, if you have plated cylinders, that's one thing you don't have to worry about. 2, it's very hard, so you're going to have Yeah, really great wear. It's difficult to break in. To a point, I don't know. I've seen some of the stuff break in even easier than other stuff. So, it just depends. But because you can't hone it and crosshatch it again, and like that sample that's going around, you can see spots where the channeling is gone, the cracking is gone. Once that happens, you're going to have high oil consumption. So I'll put oil consumption issues. But you can get that with any kind of cylinder. And it says special. Oh, I'll put possible. For the Sermachrome and the Sermanil, you had to have special rings. I forget what they were made out of, but you had to have the special ring package. It only worked on that one. What rings do you need with chrome cylinders?
Cast iron.
Just plain steel, the cheaper ones. So, cheaper rings. All right, so non-plated bores can be oversized. Now that's not every engine. Some of the bigger, more expensive engines, they don't let you do that. And how do you know they don't let you do that? Because they don't sell oversized pistons. So there's your first clue. You take an engine and bore all, spend all the money to bore 6 of them oversized, and then go to order the pistons. Like, yeah, we don't make P10s in those. Guess what you have? 6 planters. So it can be oversized. Usually P10 or P20 is about all you'll ever see. Some of them are only P10. P20 is pretty rare. Honestly, with metallurgy the way it is and the way cylinders last, it's so rare to take a cylinder and then run it all the way to TBO, right? 2,000 hours or so on it, 1,500 hours. Then overhaul it and go, yeah, I want new limits, so we're just going to bore it to 10 over. Then run it again for another 1,500, 2,000 hours and go, hey, the cylinders are doing great. Let's go P20 this time. It just doesn't happen. It's just so rare for that. Only time you do that, like you guys have some P20s, I think just because the cylinders are so rare to begin with. So usually what happens is by the time you get around 1,500 hours on them, they're already cracked. You just don't know it until you take them apart. Now you take it apart and you see it and I go, oh, they're cracked. Now you can't use them. Or you can send them out for weld repair. There are places that are approved to weld repair the cylinders, but it's usually going to crack around the welds at some point anyway again. So it's just, I don't know, it becomes this problematic thing that at some point you're better off throwing the cylinders out and buying new ones. Continental does have that P5. Continental has a plus 0.005 bore. That piston is standard, STD standard, but rings are P005, plus 5 bigger. I do think there's a Q&A question that asks about boring. So boring, oversize is limited to less than automotive. What can you bore an automotive oversize to?
Depends on the block.
So what's like the biggest you've heard of?
I don't know, honestly.
How much? 30? Okay, yeah. 40, okay. Because aircraft cylinders are thinner. And they're supposed to be nitrided. So if you had a nitrided cylinder and you bored it 10 over, what kind of cylinder do you have now?
Steel.
Plain steel. They don't consider that. They still call it a nitrided cylinder, but you don't. Yeah. Do I need to start writing nicer? Every now and then.
Don't go back to that text thing.
I won't, but every now and then somebody's got to just go, hey, could you... my hand gets tired. I have to slow down, remember. So identification. Didn't like the magic pen, huh? So identification. Let me see what we got here. Let me just check this. No, I don't have color codes in here. Identification. A cylinder bore can be identified by color code. So identification. Cylinder bore can be identified by color code. They use a bunch of different color codes. What is a continental cylinder color code for nitriding?
Orange.
No, continental color code is gold. They don't tell you. It's just, again, it's like, why? So blue, this would be a Lycoming only, is nitride. So you color code it blue, but you don't do it around the barrel like that one is. You do it up on the fins. So they have some, I don't have a Lycoming cylinder in here. So some fins are going to be blue. They'll code the fins. Like on a Lycoming, it's these fins. It's between the push rods, kind of the ones but it's on the top for them because your push rods are on top. So it would be these fins, they would do blue right there. That would be for Lycoming is nitride. It's silver stripes. 2 silver stripes.
Nice. They chose silver on a silver colored material.
They're like bright silver. Yeah. So 2 silver. I think it's a bluish silver. 2 easels. The NIC3, which is the nickel carbide. Nickel carbide. That's your Sermonil. Told you my memory was starting to fade out on that one. It's been a long time. Orange is what?
Chrome.
Chrome.
This is all for Lycoming?
Nope, that was just blue. I wrote Lycoming there. So only blue Lycoming. That's their thing. But 2 silver stripes, and that would be down below here. So now we're talking about barrel plating. When you plate the barrel, you put the color code. I take that back. I've seen it right here too. So 2 silver stripes here. I've seen it on Lycoming. You wouldn't do it on this cylinder because it's a Continental. It sits this way. And you never see that. You do it down here on the barrel on a Continental. 2 silver stripes, nickel carbide. Orange is, you guys said it, chrome. Green.
P10.
Ooh. P10. Note that is 0.010. Yellow.
P20.
Depends on position.
Depends on.
Yeah. If it's done like on a Lycoming back here where the barrel, where it had the blue, instead of blue, it's now yellow or green. So right here on a Lycoming facing up, blue, yellow, or green. If it's there, then it is P20, right? But spark plug reach. Is also color coded. And you can tell a guy did this because as a guy, we only know so many colors, right? And I don't know. Orange looks like red, so they ran out. So yellow is long reach. So you got a yellow stripe on your cylinder. You either have P20 or you have a long spark plug reach. And spark plugs, I don't want to get too much in spark plugs because Larry covers it. Spark plugs are either short. You guys have short ones in your 290. Double that in the threads. If the threads are really long, that's a long reach. And so Lycoming and Continental will put a color code indicating that they are long reach. Like these cylinders are never long reach, so it'd be ridiculous to say, but it would be right there next to the spark plug. If that was yellow, this would be long reach, and I would know that somebody was an idiot because it's not long reach, but those aren't long reach. But on the bigger bores, that is that way, yeah.
Are the spark plugs also color coded, or are they just one color?
They are color coded. I have a funny story about that. I didn't know they were color coded. They come in two colors, silver and gold. If they're silver, they're massive. They're the big one. And they're the cheap version, which is only about, nowadays, I don't know what's, you
It's
guys,
like 100. It's like $50.
yeah, they're like $50 each, right? And then the gold ones are the fine wire, iridium, and they're about $200 each. I know, I can't afford them, I don't know, but they're insanely stupid expensive. And so, the first job I had, when we would do an annual, we'd take the spark plugs out. There's two things I didn't know. One, the end of it doesn't look like a football. They're supposed to be round. And it's a bit better with the story. I thought I had a bunch of spark plugs. I used to have a bunch of spark plugs in there, but I'm like, I don't do spark plugs anymore, so I'm just going to get rid of them.
Oh, is that what those were? I'm sorry, I got
Yeah.
hungry.
So anyway, the guy's like, yeah, you got to clean the spark plugs. So, you clean them, blast them, and they're all rusty. He's like, well, blast the outside too. I'm like, so glass the whole outside, and you got to paint them. Well, what do you want to paint them? Well, here, paint them this Continental Gold. So I was constantly painting spark plugs Continental Gold that were supposed to be silver. I didn't know because, this place, nobody could afford iridium plugs. And so I don't know. For all I know, he was telling people he put in new iridium plugs. Probably not. He was an honest guy, but I laughed about that. So I'm like, that's actually a color coding. You're not supposed to paint them Continental Gold. So anyway, yeah. All right.
When they put those cylinder sleeves in there, did they do anything to do it? Or
They're not sleeved.
Oh, what barrels?
There was the Lycoming 235s did try sleeving, and it was a disaster. So they had to get rid of all the sleeved ones. But so when I worked on cylinders, yes, at the temperature 400 degrees, you can unscrew these. So if you grab this, take it about 400, 500 degrees and twist, it just unscrews. I've never tried it, but I knew in my shop I'd get a couple that were a little bit loose. So one of the first things we would do before we put it in the oven is index them down here. And that's really important because when it goes on the engine, this part is going to be set, and you don't want your head sitting cockeyed on there. It won't fit in between the other two if you have a six-cylinder. So, yes, we'd index them to make sure they stayed in alignment when you were doing the work.
How did you do it? With a marker or something, or did you?
I used a little punch. I literally just used
I was gonna ask you.
these cylinders. You can't. I would use a little electric pencil, little vibra pencil, and make a mark on each one. On all your other cylinders, the barrel and the head, there's always a spot where they're the same. So you just hit it with a punch. We just tap it with a punch and put the indents in the two. Yeah, completely approved procedure. Two types of bores. Like, wait a minute, how is there two types? We just talked about nitrating, non-nitrating. You'll know in a minute. So we have the straight bore. The straight bore, which is where the diameter, we'll say at head, is the same as the bottom. And we're talking about when they come out of the factory. So that'd be a straight bore when it came out. What it does after you run it, that's a whole different thing. But it started life out as a straight bore. And in the Lycoming world, that's an indication that it's a plain steel. They did not They did not choke the plain steel. So plain steel, straight bore. It's the way Lycoming did it. Continental, they're smaller ones. They went straight bore. The bigger bored engines went tapered. Not that that's important. It's just that's the way it is. And then we have choked. So that is where the diameter at head is smaller than diameter at opening. Okay, at room temp. If we must add that. So typical choke. Choke is 0.005 to about 0.010. It used to be more. Then we started with steel belted pistons and they brought the choke down a little bit. So that's a fair amount. If you think about it, so it's 10, so that's 5 on either side, right? So it's got smaller by 5 either side. Like, wow, that's quite a bit. Yeah, that would be like adding a piece of paper in there and rolling it up. So it's that much smaller in the grand scheme of things. But yet, you know, when you're doing it, it's like, oh, that's like that much. You know, it's 10 thousandths. It's a lot. Let me see, heat expansion. Nobody told you why it's choked, right?
Yeah.
Because there's more material at the head, and at operating temp, it expands more at the head side, and then that causes it to be straight when it's operating. So head expansion causes choke. To expand to a straight bore. At operating temps. That's why you want to warm up your air-cooled engine nice before you take off. You don't want to just start it up and go. I can tell you 2 stories. I don't think I told you before. I did an annual one time for this new customer on his crappy little 150. And yeah, I was probably mishandled by management when I gave them the squawk list and said these are all the things wrong with this airplane, and they didn't call the customer, as was typical of this management, and explain to the customer all of the things that we needed to do to annual this airplane and fix the discrepancies, and this is what your bill was going to be. They like the shock and awe approach where they say your airplane's done, and you would come down and go, holy crap, you did what? It's how much? You know, so that was bad. But this guy was a jerk. And I was doing the annual. The only thing I remember much about them, 2 things, that and I was moving the ailerons, and you know, use your ears a lot. And I move it, and I hear this click, clunk, click, clunk. And I'm like, well, it's not supposed to make that noise when you move ailerons. And you guys know what an aileron is, right? And what it does now, okay. So I have to investigate. So I am looking, and well, the cable runs up to a bell crank. Right, so you have the control wheel has cables run around, up the wings, out, goes to a bell crank. So you have one cable goes one way, one goes the other, and push, pull, and then you have a rod that comes from the aileron that goes here. Well, that rod is bolted. Well, that bolt had no nut on it, so every click clunk was it skipping a thread out until I kept doing it, and it walked itself right out because there was no nut holding this control rod to the aileron. So I'm like, damn, that was like one of the best catches I ever caught, you know, really saved somebody's life. You know, it's like, wow, I feel so good about it. Anyway, that had no bearing. When the guy came in and he paid his bill, he was really, really freaking pissed off. So he wrote the check. I love the part where the boss called me in and made me sit there and get berated for all the things that I did. I'm like, it wasn't my fault. You're the one that told him it wasn't going to be that much. Anyway, so the guy wrote on his check, he signed the check, and he wrote in a little memo. You guys know what a check is, but he wrote on the memo side, paid under protest. Which, but so this is out at Clarksburg, which is a grass runway, right? And so the airplane was out waiting for him, and it's like 90 degrees to the runway. So it's a non-controlled field, and it's all grass. So it's in between the hangars. You come out between the hangars, you turn, well, actually this way. So he's facing this way, if you want to get right, and then you come up and line up on the runway, and you take off that way. Well, he's facing this way, and he just gets in the airplane, starts it up, goes full throttle, barely makes the corner and takes off. I'm like, wow, that was. And I never heard her soft.
Donut.
I know. It's like, you showed me.
See you in a week.
Yeah.
See you in the next 100 hours.
He comes in and his whole, all of the camera of his airplane is all leaning off because he bent one of the gears.
Probably. It's grass. You can skip on it. All right. Bore surface. Wow, didn't we already do bore surface? We did, but now we're doing different bore surface. So
The outside surface.
no, it's still inside. It is honed to finish. It is honed to finish. That finish is not something arbitrary. It has what's called an RMS finish, which you should know what RMS stands for.
Root mean square.
Root mean square finish.
Oh boy, now we're talking electricity.
Yes, so it's got to have a particular finish. And that RMS, number one, you do have a crosshatch pattern that's about 45-degree crosshatch pattern all the way through it. But the RMS finish has to do with the depth and I could say aggressiveness of this finish. And so you're going to have a number that is assigned to that. And you have to measure it. So this finish is measured with, you can do one of two things. One, and I like this one, a profilometer. It's like, I probably didn't even tell you that. And you're like, it's got to be a profilometer. Which I have never seen a profilometer. But I've been told it's similar to a record player, which there's a time when I'd have to explain that to you, but I think you now know what a record player is. It has a little needle on it that goes across the cross, and it measures the depth and stuff. Or you can just use a surface roughness scale comparator block. Surface roughness scale comparator block. Block. What it is, and I thought I ordered one. It's just a little wallet kind of thing, and you open it up, and it's got two pieces of metal. And on this side, it's got all different kinds of roughnesses and the number right next to it. And so you just look at it and go, oh, well, yeah, that looks just like that one right there. And you compare it to the block that you have. It works. I had one, you know. In fact, when I told you about rocker arms and stuff, I had to get one of those and do that. So, honed to about a 45-degree crosshatch. If it's too smooth, what happens if it's too smooth?
Oil slips.
Yep, will not hold too smooth. SMOOT. Will not hold oil. Too rough.
Crap, too
What
much
does
oil.
it do? It does some, what's the term used to Cooks it. Coats it.
Nope, causes excessive wear.
Oh,
Yeah, you got these. Well, imagine if the inside of the cylinder looked like a file. What do your rings and piston look like in short order? Not too good. Huh?
Well, you
Yeah.
won't see your rings and pistons.
Yeah.
You'll see a shiny oil filter.
You see a oil filter that just had a party.
All right, where's the cylinder wear the most?
Top.
Where's that?
Cylinder wear is most near the head due to heat and pressure.
Can't be done.
So it wears most in the head, but then you taper the engine.
Yeah, it's choked, so you have more to wear.
Right. Then you said it. Oh, I guess the taper would be.
Then it's choked.
Yeah, then it would take- yeah.
Then eventually you measure it at straight. Then you measure it at its.
Yeah.
You actually, I don't know if I could do this. If you actually looked at what a barrel looks like, it's like straight, and then like a room temperature barrel, and then it starts to kind of work its way like that, and then there's a step that goes up like that. Kind of a step right there. So it's like the ring comes up and turns around right at this spot, the top ring right there. Goes the other way. It starts to wear a lot right there, and you have a step. So you get this area right here, because if you drew a straight line through it,
What is that?
it's what a poor attempt at trying to show you what the barrels actually look like on the inside. But you get this step right at the very, you might even be able to see it in that thing that was going around
Top
there.
and bottom, right?
Top ring,
Not at the bottom.
not the bottom. Top ring. You get all the way up at the top ring. Where it stops and turns around, that's where the most is. And so if you have a rigid hone, so a rigid hone is not the bottle brush thing. That's a flexible hone. It'll follow every contour and actually accentuate them. But if you have a rigid hone like I had, there's stones that are, they had various size stones, but that big around but square. Actually bigger than that. Anyway, that are going around. Well, the stones are going to go straight and run true. So if the cylinder's wavy, it knocks off the high spots and leaves the low spots. So you'd run up the stone to the top and run it around. It's called jogging it. You would then bring it back down. You take the cylinder off. You could see where it didn't touch. Just literally didn't touch, and you had to take that step out and to get it back and true. So anyway, so I want to talk about the head now. So we'll talk about the cylinder head. So important. I'm going to write it in red. Okay, we'll go back to the cylinder head. There's a lot going on with the cylinder head. And if you're just somebody who's taking a cylinder off and putting it back on, it's not really much to think about. I mean, there is, but if you actually end up working on them and you're into this kind of thing, then it becomes kind of like, wow, that's a lot going on. And by that, I mean, just the alignment of everything is so crazy. So inside this, you have a seat down here, right? That's a seat that gets inserted. And you've all had a chance now to at least see a seat fall out of a cylinder or try and take one out, okay? So you have the seat. Well, the seat sits in a seat boss. Then you have the guide. The guide sits in a guide boss. Then up here you have a rocker shaft. And the rocker shaft sits in a rocker shaft boss. And then off of the rocker shaft, you have a rocker arm that hits the top of the valve. The rocker arm has a bushing in it. The bushing then has to be true to the face of the rocker arm. Then we'll compound it a little bit more, and that you have a guide sits in the guide bore, and that guide has to be true to the boss, or true to the, they come pre-reamed, some of them you have to ream them yourself. So you have all of these alignments going on, and then you take that one step further, and then ultimately what happens is you have a valve. This is the valve right here. There's the top of the valve. And you have a rocker arm, which can be this right here, that's going to sit on top of that and press down on the valve, right? Opening it, closing it. Well, what happens after all that is said and done? Everything has to line up so that this line right here is 100% perfectly parallel to this right here that is going to push down on that. If it's not, and you end up with a situation like this, where that's the top of the valve, and the rocker arm is accentuated, hitting it like this, what's going to happen? It's going to wear out the stem. Really, not the stem. It'll wear out the stem. You get a bunch of wear here, and also wear out the guide. So you have valve wear, guide wear. Then it's going to start hitting the seat bad, and then it's going to start overheating the valve, and you're going to be stuck. So every one of these alignments has to end up being absolutely perfect. And then to make things complicated, you could be off by just the tiniest of tiny bit, and no engine manufacturer will let you true up that face of the rocker arm. None of them. You can't do anything to it. So you're stuck with what you have. And you know from your overhaul manual, they didn't make you change out rocker arms. You can use the same old nasty rocker arm with pitting and nastiness. So.
But what did you do to the rocker arms that you said you were refacing them?
Yes. So, yes, that's a get to that, but I came up with a little thing to eliminate that and have approval for that. Or I did. Yes.
Would 4313 let you do that?
Nope.
Yeah, it's an STC.
No, not an STC. You would have to have a repair station with an op spec, operation specification, or repair procedure that was approved by the FAA to allow you to do it, based on engineering data.
Hires DAR, everything's approved.
Yes. So, like I said, there's quite a bit going on there, and maybe this is a good place to stop. Probably, yep, good place to stop.
Do you have a copy of the manual that you made?
I don't think so.
What'd you do? Did you